Welcome to Summative Assessment number 2 in Power Electronics, and today we are going to solve problem set B, wherein the half-wave rectifier with a series inductor and a DC source has an AC source of 120 Vrms at 60 Hz. The DC source is 24 volts, and we will use Pspice to determine the value of the inductance, which results to a power of 50 watts absorbed by the DC source. We will use the default diode. For this problem, we are to create the circuit wherein the inductor value will be a variable. For the AC source, we will use transient sine voltage source. For the VDC, we will use simple DC voltage source. For the default diode, we will use D-break and an inductor. Now let's go to Pspice. Here in the OrCAD Pspice, we already placed the components. Now let's connect the components. Connect ground, 0 cap sim. For the amplitude, we are given a Vrms of 120 volts. Multiply it to square root of 2 and we will get 169.71 volts. Now let's input it as the amplitude voltage, frequency 60 Hz, set AC to 0, and the voltage offset to 0 also. For the inductor, we will input a variable, bracket L. For the VDC, we are given an input of 24 volts. Let's rename the sources. To set the input parameter for our inductor, let's go to Place, Part. Here in the library, we will load the special.olb file, find and load the file. After it's loaded, let's go to Part and search for PARAM. Then let's place the parameter here. After that, double click on the parameter and the property editor should pop out. To set the input parameter for our inductor, click on New Property. Let's name it L and set the initial value to 0.1. After the new property is loaded, right-click, display, and display the name and value. In the schematic, now that we set the input parameter for our inductor, let's create a new simulation profile. Choose Pspice AD. In our simulation setting, let's set our run-to time to 16.67 milliseconds in the general settings, and we will use parameter sweep. In the parameter sweep, select global parameter in the sweep variable, and enter L as the parameter name. In the linear sweep type, we will input our initial value of 0.1 and let's set our final value to 0.2 with an increment of 0.005. With the input increment value, it is expected in the simulation that the inductor value will increase by 0.005 from 0.1 until it reaches the final value of 0.2. So we can expect many waveforms wherein we can get the value of power absorbed by the DC source. Click Apply, then OK. Run Pspice. Here we can see the generated inductor values based from the input parameter values set in the parameter sweep. Go to Trace, Add Trace. In the problem, since we are looking for the power absorbed by the DC source, click on AVG, then WVDC, then click OK. Here we can see the waveforms of the power absorbed by the DC source based from the generated inductor values. Now let's look for the PDC wherein its value is 50 watts. Right-click on the waveform and click Cursor On. Move the cursor at the end of its waveform or at the end of the first period. When the cursor is already placed at the end, go to the probe cursor table. Here in the table, we can see the light green waveform yielded the power absorbed by the DC source of 51.271 watts, and the fusion waveform yielded the power absorbed by the DC source of 49.531 watts. To get the value of the inductor, here is the light green waveform symbol. Click it to see the inductor value. Here in the light green waveform that achieved a PDC of 51.271 watts, it used an inductor value of 0.14 Henry. Now let's click on the fusion waveform symbol. With the fusion waveform that achieved a PDC of 49.531 watts, it used an inductor value of 0.145 Henries. Since there is no closed form solution to exactly get the desired value of the inductor for the required PDC, we will use these to obtain inductor values as our initial and final input values in the parametric sweep simulation settings. Edit simulation profile. Now let's set the 0.145 Henry inductor value as our initial. And for our final value, we will use the 0.14 Henry. Set the increment to 0.001. After modification, click Apply, then OK. Run Pspice again. In the simulation, these are the generated inductor values based from the input values in the parametric sweep. Use the same trace expression last time. Cursor on and measure. Here in the probe cursor table, we can see that the red waveform yielded a PDC of 49.984 watts and the blue waveform yielded a PDC of 50.334 watts. Now let's obtain the inductor value by clicking on their respective symbols. The red waveform that achieved a PDC of 49.984 watts used an inductor value of 0.144 henries. So the blue waveform, which achieved a PDC of 50.334 watts, used an inductor value of 0.143 Henry. Again, let's use these newly obtained inductor values as our input setting in the parametric sweep so that we can further obtain a more accurate inductor value to achieve the required PDC of 50 watts. Let's edit again the simulation profile, set our initial value to 0.144 Henry and the final value of 0.143 Henry. Set the increment to 0.0001. Run Pspice again. These are the generated inductor values in the simulation. Load again the same trace expression for PDC. Click cursor, measure the PDC value again at the end of its waveforms. Here in the probe cursor table, we can see that the dark orange waveform yielded a PDC 49.995 watts, that is near or approximately 50 watts. And the peach waveform yielded a PDC of 50.30 watts. Now let's obtain the inductor values by clicking on their respective symbols. The dark orange waveform that achieved a PDC of 49.995 watts used an inductor value of 0.1434 Henry. Now click on the pitch symbol. The pitch waveform that achieved a PDC of 50.30 watts used an inductor value of 0.1433 Henry. Now let's test if these two inductor values will really let us obtain a PDC of 50 watts. Let's input these values for the inductor in the main circuit. In the schematic, delete parameter, set the value of the inductor to 0.1434. Then edit simulation profile, uncheck parameter sweep, general settings 6.67 milliseconds, check, then run Pspice. Add again the same trace expression for PDC. Cursor on and measure at the end. Here in the probe cursor table, using an inductor of 0.1434 Henry, we obtain the power absorbed by the DC source of 50.002 watts. Therefore, the inductor value to obtain the required PDC of 50 watts should be 0.1434 Henry. Now let's test the other inductor value. Set the inductor to 0.1443 Henry. Then run Pspice. Add a trace again to get the PDC and measured by cursor. Using 0.1443 Henry, it also yielded to a PDC value of 50.043 watts. Therefore, we obtain two inductor values that can let us obtain the required power absorbed by the DC source of approximately 50 watts.